Welcome to this episode number 2 of this series by Ozzy related to the game dev. Hello, Dockster. I hope that my sound is okay. I have let's say, a setup which is not tested. It's the first time doing this. Also from a different country, so yeah. Hello, Proton. Happy New Year, Proton, and of course, Happy New Year to everyone. This is my first stream for this year. I have to say I wanted to stream more, but yeah, 9 days with a cold stopped me from doing lots of things. So yeah. Before we continue, let me hello, Ozzy. I hope you can hear me.
I do.
Okay, perfect. So with me there is Ozzy. We will go through what he has been working on. To be honest, this stream was supposed to happen some weeks ago, but due to all the issues that I had, it was delayed. And you'll notice it from the slides also, that it was supposed to happen, let's say, a week or two before today. Of course, this is related to the game jam that ends at the end of this month, related to the car racing game jam, which I will show in a minute. So let's start with the usual ritual. Let me go to the browser. Okay, so as always, all I ask is to like the Phase 101 videos, and remember that under each video there are links to the code and other things related to that same stream or video, as in this case the last one of Ozzy. I remind you that there is the Phase 101 page to like it on Facebook, and also the Phase 101 group on Facebook if you want to join, and Commodore Dev if you want to join there. If you want to get in touch with me, the best place is Discord. Okay, the Phase 101 Discord. You can send me messages on Facebook, but I do take my time, so yeah. So if I do not answer, please be patient on Facebook, but I do always answer, okay? So it's not a question that I won't answer, it's just that I take longer. I remind you that there is this page. If you type !, book page, it gives you the link. Okay, this page is resources related to 68,000 assembly programming. There is not all the resources out there, okay? It's just those to get you started. So do not expect everything, but there's enough for you to really get started. In the meantime, I should have prepared the game jam, which I do not have. Anyway, I will show it to you later on. So we can yeah. The background behind me is, well, what I have in Malta, basically the books and all that stuff that I have. Some of them you can see they're still covered in plastic. So because normally everything is covered in plastic. Down there, you cannot see it. You see the monitor. That's my old development machine. The Amiga, there's a with the GVP, it's still in plastic. This is the on the left side. That's the GVP A530 attached to my Amiga. The Amiga through the GVP, I had a SCSI CD-ROM, SCSI 5.25-inch drive, but it used to hold 24 mega, if I remember correctly. And there's the zip drive also. So quite a number of devices. I also have a tape drive, but it's not visible, which I used to attach to the Amiga. And if I move a little bit the PC, you can see right now in operation, this is my A4000. Right now, it's being sprayed. I sprayed it black. So I have the front and top cover, which are black. And I sprayed it today, so I'm waiting it to dry up so that I can attach it again. And eventually we will be able to use real hardware in future, both if I am in Malta or if I am in UK. So this is one of the things that I want to do this year, to use the real hardware. So without further delay, we pass to Ozzy. Ozzy, welcome. Apologies from my side for delaying this episode. I know you've been hammering me to do the stream for quite some time, but I couldn't do it.
To apologize.
But yeah.
Also, it was also my fault because I was sick the week.
Yeah, first you were sick and then I was sick, so yeah, it became a mess.
When I recovered, you got sick, and actually I'm sick again because this end of the year was painful for me. I repeatedly got cold, but I had some free time in order to try to build something for the car game jam.
Mm-hmm.
And it took me more than expected because at the beginning, I remember in November, I tried something and didn't work out as I wanted.
Mm-hmm.
Then the vacation arrived, and even if I wasn't 100% healthy, things started to work like I wanted to work. So right now, I want just to show you my progress, if there is any, because this is correct me if I'm wrong, but this is the second episode.
Yes, it is the second.
And yes, and the first one was very early stages. Just an overview of what I had in mind.
Oh my god, Dockster! Oh, 10 subs, Dockster! Oh my god! And as you can see, Dockster, apologies, the bot is not working properly. So, thank you very much for donating the subs to Massimo Bonucci, to Judge Groovy, to N Sniff, Der Schemmel. I cannot say it in German, but yeah, thank you very much. I know he's one of the followers. Robo Hobby, of course you gave one to Ozzy. JJ Ballon, Jolly Roger, Amiga Life, hello Amiga Life, and Braxton Decay. Thank you very much. Anyway, the Dockster, to answer your question, no, the A4000 doesn't need. The A4000 case is metal, and it was gray. It is gray, the case. It's the original one, But by time, when you put a monitor on top of it, etc., it got all, let's say, lines on it, let's put it this way, and grooves and all that stuff. So I decided to spray it and make it nice and clean, and I decided to spray it black. And the face of the 4000, because I have the CD-ROM, which is black, and the floppy, which is black, it didn't make sense to have the case white and the rest black in it. It didn't. It really didn't. So I sprayed everything black. The only thing that I left original is the push button, the power. But I sprayed where it has I/O, to press it. I sprayed it black, that part. So it's white with I/O in it. But anyway, you will guys see it once I remount it back. So tomorrow it should be dry and it should be good back. But it's fully functional. It's how to say? It's recapped. Everything is done on it. Anyway, so Ozzy, shall we go to the slides?
In the meantime, I just want to say that I would have repainted the CD-ROM and the floppy drive or replaced because for me the Amiga must be white, absolutely.
Yeah,
I
but
even accept the yellowing for
the thing
aging,
is,
but
yeah.
black really would. But just my personal taste, because out there are solutions.
If it was me, I would have never painted it. I like them to the original, like you. But in this case, it was really, really bad. and that and I tried to find a case for the A4000, but the prices are ridiculous. So I said, okay, might as well fix what I have and leave it like that. So yeah.
What about the monitor? Is it a 1084?
No, the monitor. So okay, I have a Philips CNN. You can see it behind me. This is a Philips CNN. Yeah, but to be honest, the A4000 I don't use it with this monitor, but I use it with another Philips monitor, 19-inch, but it's LED. I have a converter. Yes, because trust me, man, my eyes are not good anymore. So I suffer when it is. I just left one with an original monitor, and the rest is I suffer. So yeah, I just.
This makes sense if you use Workbench a lot.
Yeah, of course.
Games,
no, no, for games that's why I left. That's why I left that monitor. For games, it's better but I most of the time I'm on the A4000 is programming. It's not that I really play. So yeah.
Yeah, makes sense.
What was the price of the A4000? Oh, Dockster, I got it years ago. Dockster, if I paid, I don't know. It was, if I remember correctly, it was 450 sterling when I bought it. So, but you're talking a long time ago. I mean, now you need more than 1,000, no, for it.
Are still going up.
Yeah, I mean, I don't know what is the price of it right now, but I bought it long time ago. It's one of the first things that I bought. I always wanted an A4000. So yeah, it was a dream machine.
Yeah, it's a luxury item today.
Yeah,
it costs something like a MacBook Pro.
Yeah, yes, something like that.
PDF.
The PDF. Okay, do you see it?
Yes.
Okay.
Yes. RC December update. RC stands for Rallycross. This is the name of the game. And this is a clone of another RC game, which was, as I already said last time, it was a shareware game. It was distributed by an Italian programmer. I remember the name was Fabio. I tried to ask him permission to copy his to clone. It's not a copy exactly. I just saw his game and just recreating it on my own. But I found him on LinkedIn, but he never answered my messages. Maybe he didn't even visualize. So that's it. So the game is Rallycross, and as I said before, I had a lot of improvements in the last month. The last stream was just an overview, and the new feature are the following. So display track. If I remember correctly, last time you just saw some points wandering through the screen. It was a black background, and that's it. I also remember that Face told me that displaying single pixel on Twitch could be painful. So what I did, I just took a screenshot from the game, from the actual game, the RC game, the DOS game, and it was a PNG image. I converted in IFF 8 colors, and then I just converted to RAW. So, come on, my stream is freezing again, but I don't care.
In the meantime, you have a question. A Dockster asked you, when do you actually need dual playfield? I think you will answer this either later on. Yeah.
I can say this immediately. Just one thing, since I'm not following the Twitch stream because it keeps freezing, please just report me if there are any messages in chat.
Sure. Okay.
So why double playfield? And if you notice, I said for now. And the reason is that I want to have some debug information. The points that were shown last time are still there because for me are very important. They mark where the front wheel, the back wheel, and the center of the car is calculated. So, for example, if the car hits a tree, I want to see that the pixel overlaps the tree image. So for me, it's a sort of visual debug because I can't set breakpoints exactly each time when I want to break a particular frame. So what I do is just say, okay, this is the car, and over the car, I print some useful information for debugging. But and the dual playfield helps me because I don't have to take care of the erasing the image and then repainting over and over. So it's just a temporary solution. The final release will be 5-bit planes. At least this is what I have in mind. So it means you will get 5-bit planes, 32 colors, and the sprites. This is my goal. And actually, I also have in mind to replace all the drawing routines with the relative RTG commands. So you should be able to have also this game in 256 color on RTG. Of course, you need a graphic card, and maybe I will try also to do an AGA version because it shouldn't be so hard. It's just replacing, for example, if you want to draw the car on RTG, you just replace the routine which is responsible for the drawing of the car, and you just translate in RTG. All the math behind it should be already in place. So this is why double playfield. Just for now, I hope next release will be on glorious 5-bit planes and colors and 32 colors. So as I said before, For now, there is only one car. You can play just with one car. It's a time attack mode, which is the simplest way to go to program, because you don't have to do any artificial intelligence. You don't have to deal with collisions with other cars. You don't have to do anything. You just have to deal with collisions with the obstacles that you find in the road. But other than that, it's the simplest way to go. So one car, and I'm using sprites in order to draw a car, because I don't need a very big car, and even a single sprite which is 16 pixel wide is too much for me. I want very small car, because as if you remember, we don't have scrolling. The whole track fits into the whole screen, so the car must be very small. Car map is another feature that I added, but I don't think I'm going to discuss today. And this is just a file, an extra file, which comes in pairs with the real image of the screen, so the screenshot that I was telling before, and just tells when there is an obstacle, if there is a grass, do something, if there is ice, maybe simulate some slippery road, if there is the finish line, count the track, and also allows me to divide the track in different zones, because every time, in order to avoid cheating, because you could go back to the finish line in order to make the counter of the lap work, you have to, before going to the final destination, so the finish line, you have to pass through each of the zones of the track. The physics engine has been reworked, because I didn't like how it was going before, and it was the majority of my work, actually, because I wanted something really simple and very lightweight, without overloading the CPU. And I also want to mention that this program, of course, is for Amiga, but it doesn't take advantage of the feature of the Amiga fully. Of course, there is a copper list. It's using a hardware sprites, but for example, I don't use the blitter. Just all the physics simulation is done by the CPU, so it should be easy to port on some different platform with the same processor, of course. And there is the lap count. This is one of the last features. So for now, the value 10 is hard-coded inside the program. So when you finish the lap 10 times, the program exits and you return to the workbench. So these are the 5 points, the 5 major updates that I was working on this December.
Okay, so Dockster asked you, are you saying that dual playfield works like a layer in like Photoshop?
Yeah, more or less.
Yeah, in this case, yes.
In this case, I'm using like that, because the real game is in the background layer, and my debug information are on the top layer. So while playing, I get debug information, and I realize if something is wrong or not. And of course, if I see something, then I go further and I follow up with the real debugger, Monam, or just FSUI. This is the debugger that I use. Can you please, before continuing, I'd like just to show the game, if it's possible.
Oh, yes. Okay, so.
Not the debug version, so the real version.
Yeah. So, I need to jump to the Amiga.
And in the meantime, my browser started working again. So I can see your screen.
So, let's see. RC. Okay, so this is different, yeah, and I can see the car. So,
yeah.
And you have sound also.
I don't hear anything because I'm listening you through Discord and not to Twitch.
Yeah.
But the
so
sound,
the car is here.
And the dots are over the car.
Yeah. Give me a second. Yeah, because I exited by mistake. Yeah, and the dots are over the car, so you can see the car turning, and we can even accelerate.
Yeah, the finish line is not drawn on this IFF image, and this is why I tried to make an image with GIMP or Deluxe Paint, but it's very, very hard for me. So I am in trouble generating an image like this. For me, it's really too much.
Just to make you aware, I'm using keys because I don't have a joystick here. Or I do have a joystick, but I don't know where it is right now. So
yeah, you should notice that now that you are over the white, the road should be very slippery.
Yeah, I'm noticing. You cannot really drive it.
Yeah, I made it almost unplayable because I don't know if I will live like that. I remember my best lap is 1,800 frames.
Yeah.
You are over 3,000.
Yeah, but I didn't start from the beginning. It was already. But still, it's difficult.
Yeah, it's difficult, but for me, it's not too much difficult.
As I said, I'm using the keyboard, so it's a different story.
Yeah, also this thing of the joystick has some work to do because in order to accelerate, you have to press up. But many users prefer to use the fire to accelerate and the down to brake.
Oops. Anyway, guys, you get the gist of it. This is the game. This is, episode 2, and you can still see that we have a game now working.
At least there is something that is moving on the screen.
Yeah.
And so just to answer again to Dockster, if you see closely, there are 3 dots over the car.
So
the car is a sprite.
Mm-hmm.
And the red dot is where my engine is calculating the position, the XY position of the front of the front wheel, because if you remember, to simplify things, I treat the car like a bicycle, just 2 wheels, one front wheel and just one rear wheel. So just to simplify things, when the red dot is colliding with an obstacle, I implemented some sort of bouncing, and the car will just bounce backward.
Yeah.
This is the reason. And the same happens for the green dot, which is the back wheel. Instead, if you notice closely, there is also a third dot on the center of the car, and this is what I call the car position, and this is what I use in order to compute which pixel of the track you are on. For example, the finish line, so the timer stops when the central point goes over or beyond the finish line. This is what I use as a reference.
Then Dockster asked you a question. How on earth do you know that you are following the correct way?
The correct, for example, you could go back right now and go south without doing the loop on the upper right, and this won't count as a lap because there are checkpoints on my meta language, and the meta language says before getting to the finish line, you have to pass here, 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 and here. I don't know if I answered the question.
Yeah. I think you did answer the question. Yeah. Are you indicating the checkpoints on the map?
The map here, you can't see the checkpoints. I know where they are, more or less, but in order to see the checkpoints, you have to open the file that I gave you on the Twitch stream, and there is a folder, and inside you will see the checkpoints. It's all about checkpoints.
Now
the finish line is a checkpoint. This is the final checkpoint.
Now it's undrivable. This part.
Because you have to use the brake on this part, because you have to go a very slow speed.
Well.
Also for the car, I apologize because I did these sprites. They are 8 sprites, just 8, and really, I'm really terrible at drawing. Right now, I'm looking for someone for the graphic assets because I don't know how to draw this. I'm asking some help to my channel, to my demo group members, but still now no one answered my help to my request. So right now I prefer doing things myself, and I don't want to copy, I want just to real my assets. So I prefer, even if it doesn't look like a car, it's like more I don't know, a cart. But I don't care, especially when you go 45 degrees, doesn't even seem a car after all. But as I said, these graphics assets are going to be replaced as soon as someone gives me some better stuff. Also the track, it's an IFF image, and if someone knows how to draw an image like this, just an IFF file with the resolution of 320 and the vertical resolution 240 with the 32 colors. If I get someone else knows how to do this, just give me the IFF and I will include on the game. Right now I only have one track. My plans are to load dynamically from disk the image, and so you can have a set of tracks, and every tracks will have, so you can complete 10 laps on the first track, then go to the second, third. So on a floppy disk, I should be able to include a lot of tracks, because the final executable here is, I don't know, 1/4 of the disk, and so there is plenty of space on the floppy disk to include a lot of images and other assets, of course. And that's it. You did well. 4 laps.
Oh well. Anyway, so shall we go to the slides now?
Yes. This was just to give to the audience an idea of what I'm doing, because otherwise the thing I'm going to explain later are very abstract. Because what I wanted to talk about is the math behind this and how I solved the problems.
Okay, so there is a question from Docstar. Docstar, I still see your question, even though it's a reframe. Docstar said, I'm guessing that when you hit the race line, you just check the amount If it's okay, you clear the checkpoint bits and call it a lap. Basically, is it a yes? I guess so. That's what you are doing.
Not exactly, but the concept is very similar. So the car object, let's say object is not an object, but let's say has a property which is zone counter, and it starts at 0. And when the car enters of another zone, it's increased. So it's set to 1, to 2, to 3. And it's incremented only if you hit the right zone. Only in this case. And when you reach the final, which is I think it's the eighth zone, it's reset. And this is a lap. That's how it works. But if you want to see exactly how it works, you should download the file that I gave you on chat before. And inside there is under SRC assets track 1, there is a PNG image. And if you open this, it will be much clearer.
Of course. Okay, there you go. That's how
These
you
are
are.
the zone.
Those are the zones.
Yes. When you start, you are on zone number 0, which is this dark red. And as soon as the car reaches for at least enters the second zone, the yellow zone, the counter gets increased. And then the logic says, if you before you were at let's say 0, so zone number 0, and now you are on zone number 1. So these two zones are consecutive, and so the status of the car updates and says, okay, now we are at zone number 1. Reach number 2. So you have to reach the pink zone. If you go back and you go, for example, backwards into the red zones, it doesn't count because the engine is looking for the next one, not the previous one. This forces you to follow a specific path. This is the idea. I don't know if it works. It could be that my algorithm is completely wrong. I don't know. But this is the first thing that came into my mind. And for now, it seems to work.
So, this is a good idea of this map, this mask. Let's say that because it's a mask at the end.
I didn't want to go into detail of how this method works, but I can just summarize like this. This is a PNG image, and this, of course, the game doesn't know about PNG. It just, he wants as input raw data. So this image must be converted in a chunky image. Color number 0, so an indexed chunky image. If you see color number 0 is black. So for each pixel, the engine selects the byte corresponding to the pixel and read the code. If the code is 0, in this case, you get the black. The black means you are not allowed to go there. So you can't walk there. And if the 0 is detected, the car bounces back. This is the idea, because you hit something. This is an obstacle. Otherwise, if it's not 0, it means that you can go there, so you can go over the pixel. But I need also other information. Okay, you can go there, but is it asphalt? Is it grass? Is it ice? Or whatever. So what I figure out is use the 4 bits just to specify which terrain you are on. And with 4 bits, you can specify, let's say, 16 combinations, but 0 is special, so it's let's say 15. But right now I'm just using 3. So it's ice, asphalt, and grass. But maybe tomorrow I can implement mud, for example, and the car reacts differently if you are on mud. So I just say use another color just for mud. And the upper nipple, so the 4 most significant bits, it's just a number which reflects the zone which you are on. And this is linked to what I was saying before. You have to go to zone number 1, then zone number 2, progressively, until you reach the finish line. So all this information is carried in this.
Thanks for the follow, Shadow Lighter, and welcome to the stream. Say hello. We are doing 68,000 assembly in a way coding. We are doing a game by Ozzy. He has a framework called AProcessing, and we are using his framework to do a game, car racing game, basically. Sorry, Ozzy, I interrupted you, but yeah.
No problem. No problem. But I said I think all I had to say about this method. I can add only this, that I talked about this solution also with Dario, and he didn't scream. So maybe it's a good approach.
It's a good approach. Actually, I like it. I like it,
Yeah.
actually. I do like it. Dario has good ideas.
No, the idea was mine. I shared with Dario, and Dario,
okay. Sorry then. Sorry.
approve it in some way. But the thing is that an image like this, it's quite big, because you have 320 for horizontal resolution, and you have to multiply by 240. So these are a lot of bytes for the Amiga, and we are eating memory.
Sure.
But for now, it's something that I can afford, because I'm targeting a stock A600. So I have a full megabyte of RAM available, and this thing, on my humble opinions, is doable on this machine.
Yes.
So
okay.
For now, I'm going this way. I of course can try to compress the information, but it would add additional computations to the algorithm, and I don't want to go into some complications. So for now, it works, and that's it.
So I switched this to the slide. I am back on the first slide.
Yes, go to slide number 2, because otherwise at the point we are always at the same point.
Okay, sure.
So then this is the acceleration routine, and this is where this is a very small file. There is an accelerate.s file in my zip file, and it's very small. I think it's more or less 100 lines, but I think this is the heart of the game. So all the game revolves around this 100 lines routine.
What is it called?
It's under SRC, and there is accelerate.s. It's the first one.
Yeah, there you go.
Yeah, I don't know how many lines is this file.
Not much, 63 lines.
Yeah, and I spent, I think, 2 weeks to write these 63 lines, because I reworked this part over and over again. I was never satisfied. And the reason is this routine manages the acceleration of the car. and the general behavior of the car. And it works like that. Please go back to the slide so I can help myself with the description, because I don't even remember how what this thing does. So the idea is the following. First, calculate the normalized vector according to the car heading. So if you remember, I have a variable inside the car object that tells me the degrees of the car. If the car is going, for example, toward the bottom of the screen, I get 260 degrees. If it's going up, this value is 90 degrees. If it's going right, it's 0 degrees, and if to the left, pi or 180. So I take this value and I create a normalized vector. A normalized vector, it's, let's say, a vector of length 1. This is the idea. Just the normalized version of this direction. And in order to calculate this, I just wrote a routine. It's very simple. I just take the cosine and it's the sine from a table, and that's it. So it's very easy and very fast because I don't have the normalized function on the Amiga. You have to write on your normalized function as everything, I think. And since I didn't have this tool, I just built a cosine plus sine table with, if you remember, I have a table generator on my website, and I just copy and paste this table. So I get this vector, and I add to the car velocity, so the current velocity of the car, and I limit the resulting vector according to the car max speed, blue vector. So if you go to the next slide, you should see the visual representation of what I'm saying.
Yeah.
Okay, so let's imagine that the car is going at full speed towards the right of the screen. This is the blue vector. So imagine that at frame number 0, the car is going full speed to the right, and you press the right arrow key on your Amiga. And let's say, just to simplify things, that the car instantaneously rotates 90 degrees. And the new heading is the red vector. Okay, so you have the blue vector, which is the velocity, and the red vector is the normalized vector that I was telling you before. What my routine does, and this is the simple way to achieve this, at least the simple that I found, is to add these two vectors. If you take the red vector and you add it to the blue vector, you go to the point where the purple vector ends. So it's on the lower right corner. So this is the new position. It means that my engine states that at frame number 0 plus 1, so the next frame, the car will be drawn on this particular position. But this is not all, because the new vector has a magnitude which is too much. You end up accelerating. So what I did, I just use another function that I wrote to myself, which is limit vector. And the limit vector is very similar to the magnitude vector. The only difference is it first checks if the magnitude is over a particular threshold. And if this is the case, it just shortens the vector accordingly to the max allowed magnitude. This is very similar to set magnitude, but it's not quite the same. So the final computed point is point P, because it's the sum of the two vectors, and then is limited to the max speed of the car. And if you remember, the max speed of the car is a property, is a constant, which is defined on car init.s. And each car has its own car maximum velocity. So in theory, it would be possible to add another car which has a peak speed different from the other. But this should, in my opinion, this is unfair, and I won't do that. But in theory, it's possible because it's an instance, a property of the car instance. So it works like that. Before this, let's say, solution, I came up with something more complicated, because I was calculating where the front wheel goes and do some math and trigonometry to understand where the back wheel goes, and then compute the new position, then do some interpolation in order to make this arcade style feeling to the drifting and all this stuff. You are on ice, so you have to interpolate differently. But it end up, maybe with a lot of few time, let's say, more time working on this, should be something even nicer and smooth. But I realized pretty soon that calculation and my math was getting too heavy for the Amiga. And for this reason, I reworked it from scratch. And I think this is very, very simple. It's just addition, and there is a table for the limitation of the vector. But I don't use the div function. No cycles, no loops, should be quite light. I didn't take measurements. I don't know if this engine is heavy or not. But right now, I'm not skipping a frame, so I'm pretty happy with this solution. Of course, if you add 8 cars on the track, I don't know what it will happen. Maybe it's not lightweight enough to handle the movement of 8 cars at the same time. But for now, it's how it works. I don't know if I know it's pretty complicated, even if you have a basic understanding of vectors, should be very trivial what I'm saying. But for maybe someone who is at the beginning, maybe it's hard to understand all this concept of limit a vector and normalize a vector. But anyway, again, I am suggesting to read this book.
Yeah, I don't have that book here now.
This book here is The Nature of Code. It's where I took inspiration from for all these routines. So here it's very well documented, and you don't need to know math, you don't need anything, just read this book and you probably know what a limit vector is, a normalized vector is, and how to limit it, and what is the magnitude, and etc. etc.
Yeah, I do recommend that book. Yeah, it's a must read, that book.
Yeah, I remember this summer I talked about vectors, and I thought something, but of course, reading a book is the way to go, in my opinion. Even better, you can watch Daniel's videos on YouTube.
Give me a second, Doxter. I'll give you the link to it.
I didn't understand. Can you repeat, please?
For Doxter, he asked for the book.
The book is The Nature of Code.
Yeah,
it's available on Amazon, and it's an open source book.
Yeah, and you can.
Paper.
So here is the link to it. you can read it online, but if you want, you can buy it from Amazon. It doesn't cost much, and it's a very good book when it comes to these things.
Yeah, it's a free book.
Yeah, it's a free book. Yeah.
And really, reading this vector chapter, it just takes you 1 hour of your life. I don't think more.
Here it is, the SM implementation now.
Yeah, just one moment, because you guessed it, my browser crashed again.
Is everybody having the same issues like Ozzy, or it's just Ozzy that has got issue? I mean, here it's working fine. It's Twitch for me.
I think it's my fault, because I get this error from Twitch that's saying that you need to refresh the page because the player is not performing well or something like that.
I know that Twitch had issues yesterday in Italy, in whole of Italy. So I'm not sure if that is still an issue, but definitely I do not have this here in Malta.
Yeah. Anyway, I have my copy of the PDF here, so I can continue. I just noticed that I'm not seeing your screen anymore.
To be honest, Dockster, the book I bought it. I bought the physical copy, but I send you the link to you can read it also online, and you can also download the examples if I'm not mistaken. To be honest, I didn't try the Kindle. If it's free or not, I do not know, but definitely it is free on the website that I sent you.
Yeah, big disclaimer, this book is not about Amiga or retro programming anyway. It's just a general concept applied
Yes.
to a language called AProcessing or PJ5.
Yeah.
So let's try to do this without Twitch. Slide number 4 is this is the implementation from my point of view. So the file, as you said, as we already saw, is accelerate.s, and the first part is the creation of a normalized vector according to the car heading. So where the car is pointing at. So on our image on slide number 3, the car is pointing toward the bottom of the screen. So this information, so it's 270 degrees, is stored inside the property called mover still direction offset. And the store car property is just a macro, and it's just the replacement of a move.w. And what it does, it fetches data from the car object and copies the data into somewhere, in this case, into data register 7 of our CPU. So it's just a move some value, and in parentheses A2, I remember. Just one instruction. It's a single move and nothing fancy. Just I do things like this because for me store car property makes sense. It's human readable, and move.w and some A2 register, it doesn't make sense. So I try to translate to my language as much as possible. And so D7 holds the degrees, and then I do set car property add mover acceleration offset A0, and set car property add is another macro, and this time is just a move.l. Why it's L? It's because we are computing an address, And in order to compute an address on our beloved Amiga, we need the long word. A word is not enough. So in A0, we have the address of the acceleration vector. And then I use create 2D vector from angle. And this is another macro. It's a little bit, it's not complex, but of course it's more complex than the above. And what this does, it takes, for example, let's say that we have 0 on D7. It goes into my table and fetches the cosine of 0. And the cosine of 0 is 1. And then fetches the sine of 0, which is 0. So A0 address register will point to a memory location somewhere we don't know, because it's exec on the Amiga who takes care of this. So in the memory pointed by A0, we have the first word is 1 and the second is 0. So that's it. It's how the creation works of this normalized vector. And this is just, I don't know if we want to go into that. This is, I reported a URL above, and it's github.com, Ozzyboshi, AProcessing, blobx, blah, blah, blah. And if you open this link, you should see an example of how the creation of the normalized vector works. And you can go, so...
There you go. I'm showing it.
Okay, perfect. The line is 760.
Oh. 760.
This is not accelerate.s. It's just a link on GitHub.
Yes, yes. This is where it sent me to accelerate.s.
No, it's not this. You go to slide number 4.
Yes, I am. Look, I'm going to click.
You at the middle of the page there is another URL.
There. Okay, so that one. Okay. Fair enough. Yeah, 700. Yeah, I'm there.
Okay, please, can you please enlarge your fonts and make it bigger, because I can't read it very well. Maybe because my screen is...
No. I had to make it bigger. So which line you want me to go to? 700?
774. This is where the test begins.
So 774?
No, sorry, I was mistaken. The 767.
Okay.
767. 767. Above. It's no 764. Sorry, 764.
64. There you go.
764. Okay, this is a test that I use in order to check if my routines are behaving correctly. And there is at line 764, there is move.w, which is the correspondent instruction to my macro, set card property macros. And here I'm just saying D7 is 0. So I want a new vector, a normalized vector of starting from the angle 0. And then I launch create 2D vector from angle. Before I just load the address vector 2 into A0. So A0 will it's the memory area where I'm expecting to have the result. And that's it. It's how it works. Then the following lines are just the instruction to feed data into my checker. And that's it. So,
okay, Dario.
Bye-bye, Dario. So if you go back to my
slide,
yeah, there is another link which is the test33. This is a binary file. I don't know if you have a hex editor. On Linux we have XXD.
Well, Visual Code has got a hex editor, so what?
Really?
Yeah. So
download this file, this test33 file, this one. You just click on it, the browser will open.
This one? Yeah.
Yes.
Uh-huh.
And you download this file somewhere.
Yeah.
And then you should open it with an hex editor or Visual Studio Code if Visual Studio is able to open this.
Definitely is able to. Definitely. That's all it has. Is that correct?
Yes, it's correct, because cosine of 0 is 1. So we get, we are using, if I remember correctly, 11 digits for the decimal part. So if you convert in binary, you have the first nibble should be there is the explanation, but the first nibble should be 8,000,1000, right? And the second byte should be all zeros.
Mm-hmm. That's what it says, yeah. Yeah.
Yeah. So this represents a 1. And of course, the second word is all zeros, because the sign of 0 is 0. So you get only zeros. So that's the point. The point is that, of course, sine and cosine are function, and they give you values between 1 and -1. I can't just say 0, FF, or 1.
Mm-hmm.
You have to multiply all these values because you lose all the decimal part. So what I do is I shift to the left for 10 times. And this is why I get this 8, because it's 1 bit, just 1 bit, which states the value 1.
Mm-hmm.
So that's the point, because we need to interpret what the creation of the vector is telling us. But again, this is all documented more or less on the doc of the AProcessing. This is not something that you have to worry about. So let's continue to the next slide. So it's slide number 5.
Yeah.
And this is the scaling. The normalized vector is scaled according to the power of the engine, because if you have a very strong engine, and this is a property of the car, if you put a very strong value here, the car acceleration will be instantaneously. Let's say you reach the max speed in 1 or 2 frames. If you set this too low, you will keep pressed a lot for a long time your accelerate button in order to reach the maximum speed, and you need time, you need more frames in order to achieve the maximum speed. And this is more or less what happens when you are on ice. In order to simulate a slow acceleration, I divide a lot because I want the maximum acceleration to be achieved only after a certain amount of frames. And this is what I do here. I say put the engine power into a 0 and put the acceleration vector into a 1. And then I divide. It means that I scale down according to the engine power. So this is counterintuitive because the bigger the engine power, the slower is the acceleration, but it works. But you have just to do inverse logic. So a very weak engine gives you a huge boost, and vice versa. And this is how the divide vector works, but I don't think it's necessary to go into that. Just for the curious, this is how I implemented the vector division here. And these are the tests. For example, in this test, I don't want you to open this URL, but just to know, let's say that we have vector 15, 21, and we want to divide by 7, and the final result, by 3, I think, and the final result will be 5 and 7. So just as a division from a scalar value. And of course, you will find these 3 lines on accelerate.s. As I said, if anyone wants to try, just can play with the engine power, change the values, and see how the car reacts. The movement of the car will react differently according to the engine power.
Yeah, for those that because he's saying for those that want to play with the code is available right now already on Ozzy's GitHub. I will have the code that we use today in my own folder related to this stream, but the code as such of the game is already online on Ozzy's GitHub. Okay, so if you want to have a deeper look, you can look there.
Yeah, it should also be very easy to compile if you have VASP. It's just there is a makefile inside that if you use Linux, it's really straightforward. Otherwise, you just open the makefile and figure out what's going on, which are just a few lines of code, and then you can compile. I didn't try, but I think also with DevPack, it's possible to compile, and even on ASM Pro, probably it's possible to compile because there is no weird stuff here. It's just stuff taken from the Fabio Ciucci's book. Didn't add anything else. And it must work on all the Amigas. All classic Amigas should be able to run this. So if you are able to run the Fabio Ciucci's example, probably most likely you are able to run also my program. There is absolutely no difference.
Yeah.
So I see we are approaching 11 o'clock, so maybe it's better.
It's okay. So we are slide 5. We go to slide 6.
6, yes. And this is something that we already saw in the past. This is the
accelerator
addition of 2 vectors. This is how I do it. If you remember from the slide number 3, we had a blue arrow and a red arrow. And at a certain point, I said, I add the red arrow to the blue arrow in order to add these 2 vectors. And this is the code that implements this addition. And the way I do this is I just load the acceleration vector into A0 and the velocity vector into A1, and then call my macro, which is add to the vector. So you get the addition in this way. There are other methods, and this is how I do it. Let's say it's quite fast, and the Amiga can use the add.w very easily without really no problems. You can add as many vectors as you want. You probably won't get any performance penalty.
Yeah.
And then go to number 7, which yes, and this is just the hard part. The hard part because I spent a lot of time here. I had all sort of problems and of any kind. This is what I was saying before. I want to limit the vector because each car has a maximum speed, and this is a property. And I want to make sure that there is no case when the velocity vector has a magnitude greater than. Can you hear me?
Yeah.
Okay, because my browser says stuck again.
No, you're fine. Unless the others. I mean, I can hear you properly. I'm assuming that if nobody commented, everybody's hearing you perfectly.
Okay, so I was just saying, I want to make sure that the magnitude of the vector is not greater than the max allowed velocity of the car. And how I do this with the limit function. And the way it works is like this. I load into A0 the vector that I want to limit. In this case, it's the velocity vector. And the max speed is stored into data register D7. And these are the register which my routine is expecting. And then I jump, because JSR is a jump to a subroutine. I jump to this particular address and it starts querying my tables. And my tables will just give an answer. And so the x values of the vector and the y value of the vector will be recalculated in order to have the new vector of magnitude equal to the max speed. And then, of course, we will add this to the position of the car and we get the movement. This is how the car moves. And above all, this is all the complexity which is inside the game. There is no other complexity, because how to display and print an image on the screen is very straightforward, and you can read it on Fabio Ciucci's book. It's not complicated at all. How to detect the movement of the joystick is not complicated, and also you have a good guide on the book. How to check if the car, a pixel, is over the road or a grass or whatever. It's just math, and also this is explained on the plot point routine of the Fabio Ciucci's book. What it's mine, it's just this routine, this limit to the vectors, and I don't think that in the book we have something like that. So this is my stuff, because I didn't read it on Fabio Ciucci's book. And,
no, it's not there, that part. No, it's not.
Yeah, there are some. No, I think it's nothing. There is some mention about vectors, I remember, but
It's not
going to say how to limit a vector.
Yes.
So, following, there is an example, and say there is an example that says we have, let's say, vector which is x equal 1 and y equal 1. So we are going, it's a vector pointing to the right and to the up, so 45 degrees. And we want to limit to 0.5. This means we want half of the vector. And the way it works, this is the test, but I don't want you to go there, just for the curious who want to discover what it did. But the result is 0.35355, etc. And you can verify it if you open the pj5.org. Please try to open the pj5.org URL.
Give me a second.
There is a URL on the middle of the page where there is a sketch.
Give me a second. PJ5.
Just copy and paste the URL from the PDF.
This the editor. Yes.
Yes, there is a this URL is pointing to a sketch.
Yeah.
Hopefully, if I didn't delete it, and you just paste the URL.
Yeah.
Okay, just hit play. It's on the upper left corner of the screen. And you should see on the console that you have X semicolon 0.5, etc. So my routine must give you exactly, or not with not so much precision, because I have limited bits available. And here it's using probably a double precision floating point. So I can't reproduce exactly this number. But if you go back to the PDF, you will see that my routine will do exactly the same stuff and will hold this number, or a rounded number, on the Amiga memory. So the final result is, if you go down, there is 05A0 and 05A0. This is the representation.
Yeah.
And if you want to verify this, there is this website which is exploringbinary.com, and you go there and you enter the 0.35 number, and you will see the result. I don't know if you use this website, but it's very handy.
No, I never heard of it, actually. Was it called?
Yeah, try to open this binary, exploringbinary.com, the URL which is reported on the PDF.
It's in the PDF. Sorry, I didn't. Well, it's here now.
Yeah, at the bottom of the page, there is our website. Go back to the PDF, because I gave you the direct link.
Interesting link. I never used this.
Yeah, it's very well done. Okay, now you have to fill this form. Enter a decimal number.
So if we enter this number,
0.35, etc.
Yeah.
Yes. You just copy and paste here.
Yeah. And convert, no?
No, before hitting convert, you have to, there is a field called num digits.
Num digits.
It's next to the clear button.
Yeah. And?
Okay.
What do you write there?
You have to put here the precision you want. For example, on the PDF, I think I used 12. Let me check. So it's 12.
It's not letting me to enter. It's not letting me to enter any number there.
Come on, try to reload the page. It's not active, this field.
Yeah, it's you see it's grayed out.
Yeah, it doesn't occur to me. You can't enter anything.
No,
But
it's grayed out.
maybe you are not pasting the number on the correct format.
Well, I pasted it here.
Paste it again.
Convert.
And okay, put a
There you
comma
go.
inside.
There you go. It converted to a number digits of 0.17
yes.
of precision, I guess.
You can't replace the 17 with the 12. It's very strange.
It's not letting me. No.
Okay, doesn't matter.
Well, yeah. Anyway, we got the idea. We got the gist of it. No, so.
Oh no, we truncate infinite binary fraction to 62 bits. Just put 12 on this.
This one. Okay, and then
this
convert.
One, yes.
Yeah. Now it did it. It did truncate. Yeah.
Okay. Now, if you take this number, you will recognize which is the same number that I put on the PDF. So it's the new X position. It's a 0, 1, 0, 1, 1, 0, 1, 0. And the same pattern is on the PDF. Exactly.
Yeah.
So my routine just returns this value, and and it's the last line of the PDF, and next to the binary form I put the hexadecimal, the hex form, which is 0580, I think, just to demonstrate
05A8.
Pardon, yes. And this is exactly what my test is reporting above. The test 47 is reporting the same exact number. So just to show that I tried to reproduce this PJ file limit function on the Amiga, which is very useful for these things.
Okay.
And that's it. Of course, there are a lot of tests on my AProcessing repository, how to limit. I tried to limit a negative vector, a very high value vector, etc., etc. And this is the last slide. And this is a problem that occurred to me. And I just want to make a brief mention. And these are AskQRT tables. Inside AProcessing, there are some routines that, given a number, they try to calculate the square root. And they do this just with iterations and some math. The code is not mine. I found it on GitHub, and it works. But they are not so, let's say, accurate because we don't have FPU, and the way we represent numbers without FPU, and etc. So they work, but they are not the best pick to go when you program on the stock Amigas. Above all, from a computational point of view, it's quite expensive in terms of cycles to compute a square root. So what I did, I did a new page on my Amiga font editor, and you can open my Amiga font editor URL. And there is this new table.
Just for the sake of, I'm just going to post the main website. To be honest, guys, I'm going to open this tab, and if you'll see, I have the in one of my tabs, I always have Ozzy's tools there, because there's a number of tools you can see at the top. Font, sprite position, register conversion, couple list, display window start and stop, point projection, trigonometry tables, raw to planar viewer, RGB colors. I always use this. There is this, the one of Ozzy, and the other one of I forgot who made it. Deadliners. These two websites, I have them there, and I use them for most of the stuff when I'm doing games. I'm just going to put the link. There's a number of tools that Ozzy wrote, which I do suggest to look there and you know um, use them, because there's quite a you will, if you are doing game dev, you will need these tools.
Yeah, I hope that this page can be useful to someone. But anyway,
No,
I use this.
it is very
And
useful. I'm telling you, it's one of the um, places where I go to um, for things related to game dev. So yeah.
And anyway, I just added a new tab, this is square root tables, and
Yeah.
this is very trivial. They just help you for on the process of the creation of these square root tables, because I don't want to calculate square root on the Amiga. And in order to get a magnitude of a vector, you have to use square roots. There are other means, for example, you just fake for with some trickery, but they are not accurate. And on this game, I want the math to be accurate as much as possible, because when you turn the car, I don't want the car to go some extra pixel out of the right track. I want the pixel to be calculated as accurate as possible. And so no randomness here. And what I do here, there is this list box inside next to the fixed point format. And if you click on that, it will just ask you how many decimal points of precision do you want. For example, you select Q5, Q412, which is on the bottom, 412. Yes, click on this. And then if you have a powerful PC, please click generate. It will take a while.
I clicked. Yeah.
Yeah, it takes a lot of time, but it's a one-time step.
I don't know. The CPU is not really doing much. There you go.
Working.
Yeah, there you go.
Okay, I'm delayed. So this is why it's quite slow to compute, because I put a lot of info as comments, but of course the compiler will get rid of these comments, so they are not important for the machine, and they are important for us. And this is how it works. Let's say if you want the square root of 0, you just take 0, you double by 2, because each entry is a word. As you can see, the first thing on the left is a dc.w. So this is a word. This is why we have to multiply the index by 2, and you just retrieve the square root. And this is my table, and this is where I get square roots. And of course, you can pick the precision. In this case, I use 12 bits of precision. But of course, if you don't need it, you can just go 11 or 10 or whatever. So it's not important. What I just want to say is that this table is copied and pasted inside AProcessing, this exact table in Q412 format. And this is what I use to compute square root and, of course, to limit the vector. This is, let's say, it's a very big table. It's about when you compile, it's inside the executable, and it costs about 100K, so it's too much. Of course, we can shrink it, you can cut it, and because we know that the max velocity of the car is, for example, 1.5, so anything, I don't know, beyond 2 could be cut. So you save some memory, but even if you paste all this stuff in my executable, the final executable size is 200K, so it's something that the Amiga can do. And this is what I said, what I use. Probably there is something also on Trashem1 or all these compilers. I don't know. But I prefer to do this because maybe in the future I can add my own feature, my customization. For example, add an offset to save cycles on the Amiga and put the offset directly here, and so on. So this is my solution. And please go back to the PDF. There is just a little example how to use this table. As I said, for example, we want to calculate the square root of 2, which is if you shift to the left of 12 bits, it's hex 2000, and you double it, and this is the index of the table, and you get what's inside the dc.w, which is this result, which is 001.011, etc. Again, you can just compare my result with the exploringbinary.com binary converter, and you will see that the square root is pretty accurate, or at least it's something that it makes sense on a low pulse screen. The accuracy is good for me. And that's it, I would say. This is what I had prepared for you today. I don't know if I was too verbose or...
No, I'm just going to remind them about the game. Let's put it this way. It's fair to have the Amiga on the screen. No. And you can see the car on the screen. You can hear the sound. Before I finish, I'd like to thank Ozzy, of course, for this nice stream. I hope that was informational enough for you guys to understand the logic behind such a game. Of course, it's not yet complete. Eventually it will be complete, whether he finishes by the end of the month or not. We will continue with the series. Also, I'd like to wish you all Happy New Year again. And I do apologize for not streaming. I mean, that was not the plan of having December no streams. It was literally the opposite. But I hope to start again with my streams, and I do have some plans, and one of them is a 25-day stream, so one day after the other, where I have something in particular that has been prepared for quite some time now to be streamed. So yeah. So guys, thank you very much. I hope to see you soon. I do not know when it will be my next stream, but I will be thinking, and definitely I hope to stream another stream next week at least, before I return back to UK. And this was a good test for me to. I'm just going to close it because it, for some reason, yeah. For some reason the sound didn't sound right. Hopefully I will stream again before I return back to UK, and then I should start streaming again back as I was, with my usual habit of streaming and probably annoying you with so many streams. As Ozzy says, I have too much time on my plate, which is not true. Anyway, guys, thank you very much. Have a nice week or weekend, and have a good Friday also. See you. Bye bye.
See you.